Thanks, everyone. So who am I? I'm a principal cybersecurity consultant for BSI Digital Trust, and I specialize in a couple of areas, particularly in cloud-native container security, orchestration technology, so Kubernetes in particular. And I also specialize in red teaming and purple teaming and general penetration testing. Okay, the agenda, it's go through the Kubernetes, what Kubernetes architecture is, and the deployment of risks with the Kubernetes, in particular on-premise, on bare metal. And then we'll talk about the access control as well as the authentications. And we discuss the RBAC control. And following that, I'll have 2 demos for you. Hopefully we reach that. One of them is how to compromise a service accounts in Kubernetes when it's misconfigured and gaining full control of your infrastructure, particularly Kubernetes. And then I will move on to the cloud Kubernetes architecture and discuss some of the risks and security concerns I see or I exploit when it comes to AKS, so Azure Kubernetes security risks. So the basics of Kubernetes. What's Kubernetes? It's an open source container orchestration framework, and it's developed by Google. It essentially manages it orchestrates and manages containers, such as Docker, depending what container engine you use. It could be different container engines, such as RKT. So essentially, it orchestrates and manages containers. What problem does it solve? It's basically moving away from the traditional way of doing managing servers. It divides it into very manageable, independent services. So let's say if you have an application and you want to have your payment is done by one service, your transaction on a different service, you can independently basically have these services as a container. It's not all in one server that the database is there, the application is there, and so that's essentially orchestrating the business needs. How does the architecture looks like? So this is at the core level of a Kubernetes service. There's a master API service, which is in the middle. And then you have on the etcd, which is the key value database. And then you've got kubelets, key proxies, and kube controller, as well as scheduler. So every request that needs to go through any of these basically services has to go through the kube API server. In particular, so if you can see the symbols between basically the secure certificate next to each of these components of the Kubernetes architecture, is that, for instance, etcd, it's a key value database. So you have a key and value database. Essentially, all your configurations, all your stateful information, it's secured in that database. And you have the kubelet, which manages your Kubernetes nodes. So essentially, what kubelet does, it manages the containers within the pod inside an infrastructure. And you have the scheduler, which schedules pods into these Kubernetes nodes. And then you've got the kube controller, which essentially looks at different other services, processes within the Kubernetes API. And if you pay attention to actual certificates, some of the risk I'm going to discuss particularly on premise is that the risk is around actually authentications, the traffic between those components that makes Kubernetes. So I'm just going to go through some of them. So one of the common ones I actually see, it's the API server with no TLS encryptions as well as no authentication. What that means is that you've got a Kubernetes essentially runs with no encryptions or no client authentication. So anyone can actually, within the network, could access your Kubernetes environment. In first, it's basically, there's no TLS encryption. Therefore, all your traffic is unencrypted. Second is that there's no authentication. Therefore, anyone within that network could access your API server. So essentially accessing all your secrets. And then you have this is some of the examples. I'm sorry if actually I'm not sure whether you can see the screenshots properly or not. But essentially what's happening here is that when you run a default Kubernetes, when you deploy on a bare metal, a Kubernetes, it runs on no encryptions and no authentication. So here what I'm demonstrating is I'm using basic curl, accessing the secrets on the Kubernetes API server. Because there's no authentication, because there's no authentication is being configured, therefore I can just access the Kubernetes API server and the secrets, all the configurations that is stored in the etcd database. How do you go about mitigating a Kubernetes plaintext protocol as well as client authentication? It comes down to PKI. So in most companies, probably this is integrated into your PKI Active Directory internally. But in some of the instances, that if it's just a standalone Kubernetes API, that could be mitigated by actually having generate a certificate authority, so CA. So what I'm doing here, essentially, I am creating a CA for this Kubernetes environment, which is the CA is called ca.key. This talk is happened previous year, so in 2022 in a SteelCon. So therefore that's why you see the CA still under the SteelCon CA. So, but I have updated it. So essentially mitigating the API service client and authentications, particularly you need to generate your own CA if you're not integrating into your Azure PKI environment. Following that you generated the CA, the issue with actually on-premise Kubernetes is that you still have to go back to your API server and add in those flags within the API server's configurations and restarting your API server in order to actually have this to take effect. So here, for instance, I am having the TLS cert files, which is the Kube API CRT and then the Kube API server. So I'm giving those keys in order to mitigate the plaintext issue. Here, essentially, what's happening here, once I've basically reconfigured the Kube API server, I need to restart the API server. And in this instance, as you can see, I am specifying the certificates I've generated it, and also specifying the -- insecure port 0, meaning that when the API server actually starts again, this time it needs to go through the HTTPS as opposed to HTTP, so clear text. And then in terms of actually protocol authentication from a client perspective, is you still have to generate a user certificate for a user to authenticate to API server. So here I am basically generating a key for myself, say Zane.key, and I am issuing that key. I'm basically certifying this key using the CA, the local CA that I've actually used. And as you can see in the bottom, I am doing a kubectl get secret and specifying the client authentication, my key, in order to actually access the secrets in the Kube API server. So this is no longer the case of, you can just directly access this, the API server without authentication and clear text protocol. The same issue applies to the etcd database. So the core components of the actual Kubernetes is etcd database, which is the key value database. All your configurations, all your states, all your secrets are essentially stored in that database. So if your etcd database is compromised, essentially your infrastructure is compromised on Kubernetes. So similar issues with the etcd database is that when you deploy in a bare metal environment, there are essentially no authentication, and there are also no HTTPS enabled. So in that particular, as you can see that, even the Kubernetes, when you deploy it, it says the etcd service is running on port 2379, but it's strongly discouraged because of, there are no HTTPS, or there's no HTTPS is not enabled. Also, there's no authentication. So for the other issue with the etcd database is that if you're not enabling the HTTPS authentications, imagine if you have an attacker that is actually intercept traffic between your Kubernetes client and your Kubernetes API server. What's happening here is that I'm creating a namespace called client C, and then I am pushing some secret to that database. So using the ---- form lateral client key. And what's happening here when I actually, create that secret using when HTTPS is not enabled, is that if your etcd database is compromised, if actually your database is being copied, so your member of database is copied, one could easily recursively look at that database and then find the clear text information that you've actually pushed. So your database essentially is not encrypted if you're not using the transport, as well as the information on the disk itself is not encrypted. And then client authentications, in terms of client authentication, it takes a bit of more work actually enabling authentication through the etcd database. It takes some configurations that you have to. It's not as simple as just creating client authentication for API server with the etcd. There's some steps that you need to follow to enable the authentications to the etcd database. So here, for instance, what I'm essentially doing, I am creating a new key, and the common name is etcd service, and I am essentially at the bottom, if you can see, I am basically issuing the etcd key by using the CA that I've generated. So I'm certifying that certificate for the etcd authentication database. And then again, you have to go back to the actual Kube API server to essentially adding those flags back to the Kube API server in order to make sure that the HTTPS is enabled, as well as your authentication. It's configured, takes effect basically. So you have to restart the API server again. So there's a lot of going back to the configurations, restarting. This obviously could be automated, but this is just pure actually bare metal deployment. But if you also notice that in terms of etcd database, your data is not encrypted by default. So and if you can see the flag on the actual encryption provider config, which I'm going to discuss how you can mitigate that issue as well. So how do you go about actually encrypting the database on the etcd? So you can use one of the config types called kind encryption config, and I'm here using a random generator basically, and I'm creating a key, and I'm adding that key inside the encrypt etcd.yaml. So essentially, I'm having a key now in order to encrypt and decrypt my data within the etcd database. And this is the flag. Again, you have to go back to the Kube API server in order to specify the YAML, basically the encryption's YAML file that you created, in order for that to take effect. And here, for demonstrations, when you basically use that configurations, when you encrypt your etcd database, now if your members of your database has been, let's say, compromised, even if you look at it from the recursively, so if you look to the etcd database, you can actually identify any clear text that has been pushed to that database. Okay, so that was the very brief touch around the bare metal actually deployment. So the more interesting things that's coming up now. The Kubernetes access control. So with Kubernetes access control, there are these multiple phases essentially. So when you authenticate as a client, you essentially, if you're using the kubectl, you have to go through those steps authentication, authorizations, and admission controller. So authentication, essentially, you have to have credentials to be authenticated to Kube API server. Authorization is essentially what rights you actually have, what right has been authorized for you to proceed to the next step. And then lastly is the admission controller, which is even if you have your authentication and your authorization, it's in place. If your admission controller, if your admission controller is enabled, the last decision comes down to the admission controller to allow you to make that, to reach to those objects that you have on your, Kubernetes. And that applies to the client also, as well as applies to the pods as well as service account. So in terms of authentications, multiple authentication types, I'm only covering the ones that I find it vulnerable, or at least issues with it. The X509 client certificate, which is, it's a valid certificate signed by a trusted authority. So you essentially have to issue certificate for your, developers, for instance. And then you've got the static token one, which is essentially just a CSV file. Not good. And then you've got the Kerberos and LDAP authentications and OIDC. I'm going to cover the two first ones that I find lots of issues with it every time I assess a Kubernetes environment. The one particular, client certificate is you obviously have to first sign it by your certificate authority, and you have to certify it by your own CA certificate. And what I'm doing here now, just for demonstration, I'm creating myself a client authentication key, say Zane.key, and then I am authorizing this key through my CA. And then as you can see in the bottom, I'm using this key, the client certificates, .crt, Sadi.Zane CRT, as well as the client key in order to access the Kubernetes environment. So the authentication, essentially you have to have a certificate in order to authenticate to the Kube API server. And with the static token file authentication, the issue, essentially you have to create actually a token.csv, which consists of three formats. So you've got the name, you've got the member, and you've got the groups. So Sadi Zane, so S Zane, and then you've got the member, which is 01, and then you've got the admin. So essentially what's happening here is that you giving someone access a CSV token, which that CSV token has to live on the disk on the Kube API server. So even if there's somebody compromise your cluster, they don't need to actually create new certificate, etc., etc. They can just keep, the existing credentials, copy that credentials, and use that credential for persistence. So, and because this CSV file, it's essentially you can revoke it. That remains within the environment without even knowing that actually someone's compromised your environment. So the issues with the certificate authentication, certificate-based and token authentications, certificates are stored on disk. They don't actually, long expiry date. So if the certificates are compromised, your CA essentially, if somebody has your access to your certificates for a long time, they cannot be revoked. Therefore, they have the same access if it's 2 years or 4 years or 10 years. And assigning new group to a user, new certificate need to be issued. So every time you need to assign someone to a group in a Kubernetes environment, you have to actually issue a new certificate. So with the token is that tokens are stored in a clear text. So if somebody has access to your API server, copy that token. Essentially, they have the access to your cluster a limited time. So token cannot be revoked. Authorizations in Kubernetes. We talked about authentications, authorizations. The way the authorization works within the Kubernetes environment, there are multiple objects. One is the allows always, always allow, always deny, and RBAC. So when always allow is enabled in your Kubernetes environment, you essentially allowing, basically, essentially, there's no, authorization is non-enabled. If you always deny, then it blocks all requests. And then you have RBAC, which I'm going to discuss how we go about actually what RBAC is and how we can exploit RBAC through a demonstration. And RBAC is essentially, it's a policy-based control using Kubernetes API. So it's a very granular way of controlling who has the authorizations within the Kubernetes API environment. And there is the node, which is a very special authorization, and it's between the kubelet and the API server. What is RBAC? It's a role-based access control. The role is based on the individual user within the organization, and you can be very granular who have what access within that Kubernetes environment. RBAC could also be applied to the server's account, and I see a lot of issues when too much or excessive access being assigned to a role-based to a server's account. The primary key objects with the RBAC, you've got the role binding, cluster roles, and cluster role bindings. Very mouthful. So the role essentially is a set of rules, defined set of permissions. So a role could be allow create pods or read pods or execute pods. And then you have the role binding, which assigns it basically assigns the permission defined in a role to a user, to a server. So you've created the role, and then you've got the role binding, which you assign that role binding to that role. And then you have the cluster role and the cluster role binding. The differences between the cluster role and cluster role binding is that if someone has the cluster role, a cluster role binding access, it means they have full access to all the namespaces within the Kubernetes API server. So with the role and role binding, it's a namespace specific, but with the cluster role and cluster role binding, you grant access to all the resources. So if you have a service account, for instance, that is being assigned cluster role and cluster role binding, and that service account is compromised, essentially that service account could, access all the namespaces within your Kubernetes environment. That applies on the premise as well as on the cloud. No difference. What this RBAC looks like in configurations is just a case of -- authorization mode equal RBAC. So that's what basically enables the RBAC authorizations. So how do you go about actually creating a role-based access control, a role and role binding to a user? I'm using basically CF SSL, which is the Cloudflare SSL. I'm creating a user called a dev user. I am also creating essentially I'm creating a dev user key and dev user CSR, and I am using I'm using the configurations essentially to create myself a certificate, which is using the actual CSR that I've created, dev users.csr. So once I've done that, I can apply that to the Kube API server. So I'm creating myself a user, and I'm going to apply roles and role binding to that user. So here, what I'm doing is that I'm looking at once I applied that CSR, I'm looking at kubectl get CSR. As you can see, it's pending, of course, and it's created by the master client. So I've created it. And then it's down to the administrator to, whether approve that user or not. So which is at the bottom, as you can see, its certificate has been approved for the dev user. And in terms of the roles and role bindings, what I'm doing essentially here is I'm creating a role called create pods that's specific to RBAC, and that create pods essentially has these permissions. So it has these verbs, so it can get, watch, list, and create. So it basically, these are quite specific permissions within the RBAC, and it's also has the access to pod /exec, which is executing into pod, so essentially having access to the inside a pod, so to a CLI. So this is the actual role called create pods. And then the role binding itself, you create a role bindings, and it's this role bindings called the read pods. And if you look at the kind, I'm specifying the role, and I'm also saying the name should be the create pods. So, and the user should be dev user. So essentially, I have a user that has a specific roles, and then specific role binding assigned to that particular user to access particular namespace. Let's say having get, list, and watch and exec into that pod. Quite specific, granular in terms of accessing to that cluster. And I guess quick case study, I've recently basically was working with a client of mine, and I came across a similar case where the client had a Grafana Enterprise 8.3.0, which is it's vulnerable to file traversal vulnerability. And what I'm doing here, what I'm demonstrating here essentially is this is just a standard YAML file for Grafana. So a pod container with a container which contains a Grafana, and it's running on the TCP port 3000 by default. And it's, if you can notice at the bottom, it's basically assigned to a service account, which I created. It's called overprivileged. So what I'm essentially trying to do here is that there's a vulnerability in the Grafana. I'm going to, which that Grafana is assigned a service account called overprivileged, and that overprivileged service account has cluster role and cluster role binding permissions. If I compromise the service account through a vulnerability, I can use that service account, compromise the entire infrastructure. For instance, having access to the kube system namespace. So here I am quickly demonstrating what the cluster role looks like when it's applied to that cluster role. Basically is applied to that privileged service account known as overprivileged role. So this privileged role has basically access to ports, create also listing secrets. So if I compromise this, I can list secrets, I can create pods into any namespace I want. This is a cluster role, not a role. If you can see at the top, kind type, cluster role. And the cluster role binding, essentially what it says, I want the overprivileged role to be assigned to a service account known as overprivileged in the namespace of secure. So that Grafana is basically deployed inside a namespace called secure. Now this Grafana has a service account with a very high privileged permissions. So if anyone compromises the Grafana, they can take that token and then compromise your entire infrastructure. And I'm going to demo this quickly for you. So here I'm just showing what the service accounts actually, the overprivileged service account assigned to which namespace. And this service account, the kubectl get service account overprivileged, essentially is, it's assigned to a namespace called secure. And for demonstrations, what I want to do actually demonstrate is that, imagine if you have a vulnerable container in one of your namespaces, for instance, a default namespace, and it's assigned a default service account. And if somebody managed to compromise your container, a vulnerable container in any basically, let's say that default namespace, they can leverage the vulnerability in a different namespace, for instance, Grafana, taking that token and then compromise your entire infrastructure. So this YAML file, I'm just demonstrating, I'm creating a BusyBox image. It's called BusyBox. It's actually called bad BusyBox. And if you look at the service account, it says default. So it's assigned a service account default, which has no permissions. So very limited permissions. So here, what I'm doing essentially, I am executing into the bad BusyBox container. And then following that, if you can see, I'm doing a quick nmap scan I'm looking for port 3000 because I know the Grafana is on there. And as you can see, the port 3000 is on, but it's on a different namespace, which is on a secure namespace. So I can identify now port 3000 running. So Grafana is running on a different namespace in a different container. So in a BusyBox. And now I am essentially what I'm doing is I'm just doing some enumerations. For instance, I'm looking at the environmental variable inside the BusyBox. It's clearly running this pod is deployed within the Kubernetes. And the next thing I'm going to do, I'm going to copy the kubectl on the middle. I'm copying the kubectl so that I can actually start interacting with the environment. As you can see, I'm using kubectl auth cani -- list. So I'm trying to identify what permissions I have in terms of service account on that BusyBox bad busybox image. As you can see, it's essentially at the bottom, I have no permissions. I don't have any permissions that I can abuse the existing default service account to gain access or escalate my privilege within the cluster. So now that I basically know there's a vulnerability within the Grafana, what I'm abusing here is that essentially, I'm very sorry, actually, it's not very clear, but I know that Grafana is running a old version and is vulnerable to directory traversal vulnerability, which is essentially what you can do is you can exploit that vulnerability to read file on the Grafana's file system. So I am now reading something on using the busybox, using basically the var run services kubernetes.io service account token. So I'm reading the token from the Grafana. So from the busybox pod, I've compromised. Now I am using that service account, the token, the JWD token, and I am using the kubectl auth canai token, the new token. So now I am from the busybox. If you can see at the bottom, basically it says I have a secret access to secret, which means that I can also get secrets and create secrets. So now that I can, from the bad busybox, compromised a new token in a different namespace, which has more permissions assigned to, has the cluster role and cluster role binding assigned to it. What I can do is now I can use my busybox as a pivoting point into the cluster. So using new service token, I can access secrets on the kube system namespace, which is essentially if somebody compromises your kube system namespace, that your entire infrastructure is compromised because it contains all the secrets that you can leverage them to read, to access any other pods within the your cluster environment. And then now that I have the token, what I can do, I can use the busybox with the new token that I've assigned to myself, I stole from the Grafana, access the kube system namespace using that token. Now I can basically list all the tokens in the kube system, which is specified at the top. So kubectl get secret hyphen kube system hyphen token and the environmental variable, which is token. I've basically taken the token from the Grafana's service account in order to escalate my privilege, and now I have full access to all the namespaces within the cluster. There's a demo, but I'm not sure if that's going to, if you can see or not, but I can definitely take you through it. So I am on my attacking machine. Essentially what I'm doing, I am looking at all the namespaces. I can kubectl get pod. I want to see what pod exists in a namespace of secure. So there's actually a Grafana. And then I am also looking at the default namespace, which has a busybox running. So two different namespaces. Now I am executing into the busybox image. Just imagine that I've compromised this through some kind of application vulnerability. Now I am inside the busybox. I'm looking at the environmental variable. Okay. I'm in a Kubernetes environment. So first thing I would do is I would download the kubectl client, which is essentially you can use that to interact with your with the Kubernetes API server. Now that I am going to basically in Bash, which is I'm in a Bash environment, and I am basically checking, kubectl auth can I list. I'm just looking at my default service account permissions to see what permissions I have. I'm still not an overprivileged account. I still can't do much. So I'm just looking at see what permissions I have. As you can see, actually, it just says forbidden. You don't have much of a privilege on this vulnerable busybox pod. Now I'm doing looking at the permissions on the BusyBox, whether I have any permissions. I have no permissions with that service account, which is the default service account, doesn't have permissions to do anything useful in terms of attacking the cluster. But what I'm doing now, I'm looking at the IP, what's my IP addresses, and based on that, I'm looking at the port 3000, which is the Grafana's default port. And okay, the port is there. The Grafana is basically running on that cluster in a different namespace. And now that I know actually this Grafana is vulnerable to a directory file traversal vulnerability, which means you can use this vulnerability to read the token on the Grafana pod. And I know the pod this pod is assigned a very high privileged account, permissions. So now I've just demonstrated using the file traversal vulnerability to see if I can list any files. I did /etcd password just to see if I can read the password file on the Grafana. Yes, I can. So now that I am just going to look for in Kubernetes, there's a particular directory where the tokens are saved. So I'm just trying to retrieve the token on the Grafana and use that token in order to elevate my privilege on that cluster. So now that I know it's file traversal, it's a vulnerability here. So I'm just gonna look for that token on the remote Grafana's pod. As you can see, it's basically the Kubernetes.io secrets and then token. So that if I can get that token on the remote pod, which as you can see is a JWT token, I can use that token, which is a different service account assigned a lot of permissions, and use that in my BusyBox pod in order to elevate my privilege on the cluster. So now I'm just assigning that token to a variable. So I'm exporting that locally to my BusyBox container. Now I use basically kubectl auth --list --token, and that specify the new token that I've compromised from the Grafana. So I'm no longer using the actual default token. I'm using the token from Grafana. And now we saw the Grafana's token. It has cluster role and cluster role binding by listing secrets and creating new pods. Now I can use the BusyBox to fully compromise the kubectl system namespace. I think it's very hard to see. I apologize. I wasn't expecting that at all. But I think I've described what the attack is essentially. So now I'm looking at what permissions I have with that token. And at the top, it basically says you have create and get. And at the bottom here, it says you have listing secrets with that new token. And then I use that token to compromise the infrastructure. So if I quickly, basically, I'm sorry, the video wasn't great. The screenshots are, for some reason, they're blurry, but if I quickly move on to the actual cloud Kubernetes service architecture. So the architecture with AKS or any other cloud is different. You no longer basically manage from the cloud perspective, you no longer manage the Kube API server or etcd. So you have no access to those etcd and control manager, as well as the Kube API server. So it's a shared responsibility. It means that in this instance, the cloud provider, Microsoft, manages all that, but your responsibility as a customer, you've got access. You're responsible for AK's nodes. So essentially, the nodes that makes the cluster is your responsibility in terms of security. So I'm going to look at some of the default security concerns with Azure environment. Some of the issues that I see, a most of clients that actually I work with, and it seems that they're failing on the followings. One is the pod security admissions, PSA. By default, PSA on 1.23 onward, it's enabled, but it's not, essentially it's enabled, but it's not in a restricted or enforced mode, meaning that your, the admission controllers are enabled, but they're not doing what they're supposed to be doing. And there's the network security and network policy, and then there's a secret. So I'm going to go through each of them. So first thing first, I need to describe what pod security admission is in Azure. Pod security admissions, it's a technical control and enforces the pod security standards. So PSI basically on pods running a namespace. What it means in short is that the PSA decides whether a pod should run on your cluster or not. Even if a developer has the authentication, even authorization is applied, if the pod security is applied and it's enabled and it's enforced in mode, for instance, the pod security PSA basically decide whether this pod should be in that environment or not. And the pod security works in, it has two objects, which is the pod security levels and the pod security modes. The level, it's privileged, baseline, and restricted, which is the privilege is that everything gets allowed. If you enable pod security PSA with a privileged, essentially you're allowing everything into your cluster in terms of PSA, and you have the baseline and restricted. The baseline mode is essentially a set of rules that its admission controller applies to your pod. It could be things like, okay, don't run your pod with a privileged security context. Don't allow a pod to obtain lots of resources, for instance. And you have the restricted, which is, I would recommend, is that your PSA, essentially, it's in a very restricted mode, only allows specific templates to basically get stored on your node. So essentially, a pod in your node. And then you have the enforce, audit, warn. Essentially, if you enforce it, it is applied. And so, if it's an audit, it only audits, but it doesn't do much. It still allows the pod to be deployed. And then, and the last one is warn, which is even if you enabled a admission controller in AKS, and what happens here is that even if it's enabled, but it sets to warning mode, it just warns the developer, okay, this template is actually not good. It's not, it's not based on the standards. It's not a good security practice, but it still persists on your environment. So it still allows it. So for instance, here is that a case study, which most of the time when I test an environment, I quite easily gain access to when admission controller, when PSA is not enabled, I can fully compromise the AKS nodes by simply basically using a template like this, a simple manifest file, which is what it is here is that I have a port called hacker node port, and it has those specs, basically very privileged specs specified. So host network, host PID, host IPC, and it's, if you look at in the middle, which is the security context, which is the key one, it says privileged equal true. And then mounting path, which is /host. Essentially, it says if I apply this to a AKS cluster, what it does, it mounts the host, basically file system, which is a server on AKS. And what happens is if I apply this, and I can cheer root into the host mounting file, and I fully compromise the actual AKS node. So I can essentially compromise the server that makes your Kubernetes API. So all your basically containers stays on nodes. And if I can quickly show you how this is done, for this, for example, the workload, the manifest I just showed you, what I'm doing, I'm applying the workload template to a namespace called secure, and it creates a pod. And then once I created the pod, basically it mounts the AKS node file system. Now I am simply exiting into the pod that I've created. And then here if you can see, I'm doing kubeexec --IT, which is interactive, into the pod, and then in the namespace secure, and then I'm doing a sh, so a shell. I'm going inside the shell, inside that hacker pod, and then here I'm doing chroot /host. What it does is routing it basically into the AKS pod. I'm no longer, AKS basically node. I'm no longer inside the actual, the hacker pod. I am now in your AKS file system. So I'm in the AKS node. So in the service. And this is the demo. I think it's probably not, I'm not sure whether you can see it or not, but okay, I'm going to move that, I think, because as you can see it. And so once you basically, this is how you compromise AKS node, but if you decided to apply if you apply the PSA correctly and you push the enforce mode, what you could do is you can enable the PSA on your AKS cluster, and in the enforce mode, I'm basically, once I enable this here, I'm enabling it here, and based on a label. Now I am trying to apply the same, I'm applying the same vulnerable or overprivileged pod I've created earlier, kubectl apply fttp.yaml in the secure namespace. I can no longer do that, basically, because PSA is instantly denying, saying, okay, you are trying to do, you've got the security context privilege equal true, and you've got your images basically mounting a file system on the share. So it applies the default enforced privileged PSA rules on that cluster. I can no longer, even if I want to actually make it vulnerable, it's not possible because it's in enforced mode, the PSA. The other issues that I do see is the networking, and in particular, networking in Kubernetes is actually complex. You've got the internal and the external, the same concept. Internal traffic that facilitate communication between pods and nodes. So when you create your networking, essentially you want to have, or you don't necessarily want to have communication between your pod in one namespace to another namespace. And then you've got the external network, which you want your workload that, whether you want your workload to connect to the internet or not, in terms of networking. The security concerns with that is the biggest one that I see, which quite often is the Kubernetes API server. So the main API server it's deployed, but is not restricted to your own network. So you don't have, anyone can access to your API server. You haven't whitelisted your API server to only your network. And this is just an example. This is just an example of basically, if somebody compromises any pods in your network, and they can take the token and then they can access your API server anywhere because you haven't you haven't whitelisted your API server to your network. So my recommendation would be, the first thing at least you want to do is that you want to restrict your API server to only your network. You don't want to just be exposed to the public, because any vulnerabilities in your cluster would somehow give access to an attacker, direct access to your Kubernetes cluster. I think I'm conscious of time. Yeah, I think I've got a couple more slides, but I think the other one is the other issue is with your metadata within your Kubernetes API server. It's just not restricted. So you want to basically restrict your metadata inside your pods. So you don't want anyone in the pod retrieve metadata in your Azure environment. So you can do that through network policy. I'm just going to be fast here. And this is the steps. I can share the slides, how you can go about actually deploying those controls in terms of restricting metadata within your AKS cluster. And then also from any pod within any, in AKS environment, you can directly nmap or scan to your cluster, and you can see this SSH basically running on your nodes. So you want to obviously restrict that as well. And you want to obviously isolate the pods ingress policy. You don't want all the pods within different namespaces to talk to each other. It needs to be quite specific. 2 more slides. And then you can do this using basically ingress and then, using select types. So you can say, I want a pod A from cluster, from namespace default only connect to, pod B in a namespace secure. So you don't want all the pods to communicate to each other, because that's how bad things happens. And then you've got the explicit communications, which you only allow particular nodes, pods to go outside of the Kubernetes API server, so connecting to internet. And lastly is the Kubernetes secret. Secrets are not encrypted. It's base 64. You want to use some third-party providers to manage your secrets. As I mentioned, it's all base 64. So use open source solutions, CyberArk, HashiCorp, etc. And that's all. Sorry, that was very quick. Any questions? I think he's just waving someone else. Sure, go ahead. Yes.
Kind of plugins for checking Kubernetes. How many of the things you talked about would be covered by that?
Actually, Defender for cloud only identified one of the issues, which is restrict your API server to outside. The rest of it doesn't cover. Any other questions? Okay.
Thank you so much.
Thank you.